afternoon. Based on the series of the limiting factor, we initially took a limiting factor of material using Ican, one Ican past question. We'll be taking limiting factor that has to do with time or hour using March/July 2020 question 1. And please, you will help us read the question, then we'll pick the requirements one after the other.
March/July 2020 question 1, limiting factor of hour. Benko Limited produces two critical components, K and T, both of which are used in petroleum refinery. The components are made by passing each one through two fully automatic computer-controlled machine lines, A and B, with respective maximum capacity of 13,600 hours and 15,360 hours. The following details are available. 1. Due to production constraints, the company has decided to produce only one of the two components, K or T, for next period, but not both. 2. Market demand is limited to 59,200 units of K and 80,000 units of T. Product units data. Selling price for K we have 900 naira and for T we have 800 naira. Machine time in hours. Line A we have 0.25 and line B we have 0.20. For T, line A is 0.15 and for line B we have 0.225. The raw material X per kg for K is 2 and for T is 2. 4. The maximum quantity of material X available is 136,000 kg. The material is purchased at 15 naira per kg. 5. Variable machine overhead for machine line A and line B is estimated at 500 naira and 600 naira per machine hour respectively. 6. Company operates a JIT system, just in one-time system. Required. A. Calculate which of the components, K or T, should be produced and sold in the year in order to maximize profits. You should state the number of units to be produced and sold and the resulting contribution. B. Benko Limited wishes to consider additional sales outlets which could earn contribution at the rate of 400 naira and 600 naira per machine hour for machine line A and line B respectively. Such additional sales outlets would be taken up only to utilize any surplus hours not required for the production of the components. Calculate whether Benko Limited should now produce either component, K or T, and what quantity to be produced and the resulting contribution.
Okay, we'll now take the solutions to the question. The A part says we should calculate which of the components, K or T, should be produced and sold in the year in order to maximize profits. You should state the number of units to be produced and sold and the resulting contribution. So we'll start with, we have machine time A and B. We start with machine time A. Under machine time A, we have K and we have T. We equally have machine time B. Under machine time B, we equally have K and we have T. Then, clearly we also have material which is limited. We have material X. This is material X. We have K and we equally have T. Now we are limited based on what we have here. They say material is what? 136,000. Material maximum of 136,000. Then equally we are limited in units for let's say market demand limited to 59,000 units for K. So K 59,000 units, 59,200 units. Then T, let's say it is 80,000 units. 80,000 units. So these are our limitations. For machine time A, for K, we have an hour that is provided here. They said each one through two fully automatic computer controlled machine lines, A and B, with respective maximum capacity of 13,600 hours. That is for A, 13,600 hours, and we have 15,360 hours for B. So here we have 13,600. I'll divide it by, clearly here they told us that under K we have line A, which is this. Line A we have 0.25 under K, line A 0.25. So I'll divide this by 0.25. Then under T we also have line A, which is 0.15. So here I'm dividing by 0.15. So that will give us the units. So 13,600 hours divided by 0.25 will give us what?
54,400.
54,400 units. Then here will give us what?
90,660.
90,660 units. Okay? Then under machine time B, for machine time B we have K. Machine time B we have K to be 0.20, and here we are working with 15,000 watts. 360. We have 15,360. I'll divide this. 15,360 under K, line B, is 0.20. So this is 0.20. Still, under T, line B, 0.225. So this is 0.225. So this will give us what?
76,800.
76,800. 76,800. And this?
68,266.
68 what?
266.
266. Then for material S, they clearly told us that we have 2 under K and 2 under T. So we have the 136,000 divided by 2. Here equally 136,000 divided by 2. This will give us what?
68,000.
68,000. So this is 68,000. This is equally 68,000. Okay, we'll look out for which one has the what. These are units. These are units. Units. The smallest units for each of K and T. Here clearly we have the smaller units or the smallest unit for K being 54,400, and the smallest unit for T being what? 68,000. Abi?
Yes.
Alright. So we'll be working with K equal to 54,400 units. I'll be working with T equal to 68,000 units. So we are going to wipe the board and proceed to computation of variable costs. Then from there we'll get the contribution. Then we'll know the contribution per unit, then multiply it by the units to get the individual contributions, so that we can answer the A part of the equation. So let's take the variable costs. Let's take the variable costs. So the variable costs, the variable costs will have for K and for T. Variable costs for K. Clearly here we have material. Raw material they say 2. But they say the maximum quantity of material X available is 136,000. The material is purchased at 50 naira per kg. So material X will have 2 times 50 naira, which is per kg, is equal to 100 naira. Abi?
Yes.
Then clearly here too, we have machine time. Abi?
Machine line A.
Machine line A, and we'll have a machine line B. And what are their prices? They say variable machine overhead for machine line A and machine line B is estimated at 500 naira and 600 naira per machine hour respectively. So machine line A, we have machine line B. For line A, what do we have here? We have 0.25 under K. 0.25 multiplied by what? 500. Abi?
Yes.
So we have 0.25 times 500. Then under K for machine B or line B, under K we have 0.20. Abi?
Yes.
0.20 times 600. So this gives us what?
Okay, the machine line A is 125 naira.
125 naira, 125 naira.
Then for B is 120.
120.
Yes.
And the total will give us what? Is the country variable cost of contribution, variable costs as per unit. Variable cost per unit. What do we have?
345.
345. So this is 345. Then we'll go for T. For the T we have material X. Material X is 2 times 50 naira still, which gives us 100 naira. Abi?
Yes.
Then we'll have machine A. We probably have machine B. So machine A under T, machine A is 0.15. Abi?
Yes.
0.15 times 500. Then here we have 0.225. 0.225 times 600, which will give us what?
75 for
75 for what? This?
yes. Then the other one is 135.
135. Total is giving us what? That is variable costs per unit. That is for T. This is what?
310.
310.
Yes.
So we have gotten the individual variable costs for K and T. Now, to get the variable cost per unit, I think I'll squeeze in here to get the variable cost per unit. Variable costs per, the contribution per unit, contribution per unit. The contribution per unit we take for each of the products. Contribution per unit for K. The contribution per unit for K. The sales price for K is what?
900 naira.
900 less the variable cost of what?
345.
345. And the contribution per unit gives us what?
555 naira.
555 naira. Abi? For T, we have what? Selling
800.
price 800 minus contribution per unit 310, which will give us what?
490.
490 contribution per unit. So these are their contributions per unit. We are going to proceed to get the total contribution. Total contribution based on the outputs that we choose in the previous values that are white. So total contribution for each of them, then we make our choice. Total contribution for each. So total contribution for X, sorry for T, total contribution. Total contribution we'll have for T. What was the unit for T?
68,000.
68,000 for T. What was the variable cost per unit?
490.
Sorry, the contribution per unit. 4 what?
90.
490 times this. Then for K we'll have the contribution per unit to be what?
555.
555. The units are what?
68,000.
Units for K.
Sorry. 54,400.
54,400. So if you multiply 490 by 68,000, we'll be having what?
33 million.
33 million. So we'll have 33 million. 33 million,
320,000.
320,000. Then this will give us what?
30 million.
30 million.
192,000.
192,000. Clearly, we can see that for T gives us the highest contribution. T gives us the highest contribution. So they should produce T because it gives the highest contribution. So that's it for the A part of the question. So we proceed to the B. The B says, Benko Limited wishes to consider additional sales outlets which would earn contribution at the rate of 400 naira and 600 naira. Recall that the initial hour was 500 and 600 per machine hour for machine line A and line B respectively. Such additional sales outlets would be taken up only to utilize any surplus hours not required for the production of the components. Calculate whether Benko Limited should now produce either components K or T and what quality to be produced and the resulting contribution. Now, we'll find out those that have surplus and whether they have surplus or not. So starting with
K.
K. Under K, we have what and what? We have
Machine.
Machine A. We have machine B. Abi?
Yes.
Now, K, we have an hour or so that they gave us, the hours they gave to us. They say A and B with respective maximum capacity of 13,600 hours and 15,360 hours for A and B. So for A, we have 13,600. Abi?
Yes.
13,600 minus what was used for A initially?
54,400.
54,400 multiplied by what was used here? 0.25. 0.25. So that would give us what?
0.
0. So this is 0. So no surplus. No surplus. No surplus for this. Here we'll have 15,000 watts. 15,360 minus what was initially used? Under K,
54,
still
400.
54, 400. Then for K, under line B, you have 0.20, right?
Yes.
0.20. So this will give us
4,480 spare time.
4,480. 4,480 spare time. Then we'll do for T. For T, we have machine A. We only have machine B. Now for machine A, for T, under A, you see have 13.6, sabi?
Yes.
13.6 minus what was used for T? 68,000, abi?
Yes.
68,000 times for T under A, you have 0.15, shape?
Yes.
0.15. This will give us what?
3,400.
3,400 spare time. 3,400 spare time. Then here we have 15,360 minus what was used, 68,000. So under T for B, you have 0.225. 0.225. This will give us what?
60.
60. So the spare time is 60 hours spare time. So these are the spare time values that we are going to use. The surplus value, because the question clearly stated that they'll be working based on the surplus values. So we'll be working with the surplus values. I can wipe this, then proceed to work with these surplus values. If we are working with a surplus value for K under what?
A.
Machine A. Machine A, do you have any surplus?
No.
No, so 0. Machine B, do you have a surplus?
Yes.
How will you want?
4,480.
4,480. 4,480 times, what is the new price that they said they have for, that is, they said for A and B would be what? 400 and 600. So the B is 600, Abi?
Yes.
So this will be times 600, which will give us what?
2 million.
2 million.
688,000.
688,000.
Yes.
Then I'll bring in the initial contribution. Initial contribution for K is what?
30 million.
30 million.
192,000.
192,000. Now the total, if I'm including that spare time that we have used, will be what?
32 million. 880,000.
880,000. Then I'll go for T. For T, we have machine A. We equally have machine B. Machine A, was there spare time?
Yes.
What?
3,400.
3,400 times how much? 400. Here, there is spare time of 60 times 600. So this will give us what?
1,360,000.
1,360,000. Here will give us
36,000.
36,000. Then I will bring in my initial contribution. Initial contribution for T is what?
33 million.
33 million.
320,000.
320,000. Now the total contribution after this surplus time have been used to the what?
34,000.
34 million.
34 million, sorry.
34 million.
716,000.
34 million. 716,000. Now, comparing their contributions, you will see that for T, the contribution is still higher than K. So we are still going to choose we are still going to choose T since the contribution is higher. Since the contribution is higher, we are still going to use T. So that brings us to the end of the question. I hope you find this video useful for your preparation towards the Ican forthcoming examinations. Thank you very much.